The midpoint formula. The midpoint of a line segment formula is what you see now on your screen. The midpoint formula is simply the average of the x's and the average of the y's. So your x value, your x midpoint, is the average of the x's, and the y value of your midpoint is the average of the y's. So going back up to our example, I like to work from left to right. Here's coordinate number 1, coordinate number 2, and we're trying to find the two missing values of the midpoint. So this xy coordinate here is the midpoint we are trying to find. At this juncture, we're going to sub in our values. The midpoint that we're trying to find is equal to x1, which is -2, plus x2, which is 4. And you're finding the average, so you're dividing by 2. Same thing for y. y1 is -3, y2 is 7. We're adding and dividing by 2. So our midpoint coordinate is now, when we simplify, 2 over 2 and 4 over 2. Our midpoint coordinate now becomes 1, 2. So we can take that back up to our diagram, and our midpoint is 1, 2. So when you're using the midpoint formula to find the actual midpoint, average of the x's, average of the y's. We can take that same information and pull it apart to find an endpoint. So you can see that my x value is the average of the x's, and my y value is the average of the y's. All I've done is taken the original and pulled it apart a little bit. Now in this case, I'm going to label my diagram exactly the same way. This is coordinate number 1, this is coordinate number 2, and this is the midpoint. I'm going to sub in my midpoint values where they go. So the x value of the midpoint is 4, and the y value of the midpoint is 17. On the x side, I'm going to take the x value from coordinate number 1. I'm trying to find this one. I have no idea what it is. I no longer need the subscripts, so I'm just going to put x and divide that by 2. On the y side, I know the y coordinate is -7. No idea what the other one is. Again, I'm going to lose the subscript. I no longer need to distinguish, and divide by 2. A couple of different ways you can solve for x here. You can clear the fraction by multiplying both sides by 2, or you can cross multiply. Cross multiplication, I feel, is the most efficient way. So 2 times 4 is going to equal 1 times -2 plus x. Remember, there's a hidden 1 or an invisible 1 under every whole number. So if I cross multiply, it becomes 2 times 4 equals 1 times -2 plus x. This becomes 8. 1 times anything is itself. Bring the 2 across, becomes positive, and then the x portion of that coordinate is 10. Do the same thing on the y side, cross multiply. This becomes 2 times 17. I'm not going to write the 1 times the -7 plus y. There's no need to, because you're going to end up with the same value that you have seen on the screen. And 34 now equals -7 plus y. Bringing this -7 across, it becomes +7, and y now equals 41. So our coordinate on the end is 1041. And those are the two ways to use the midpoint of a line segment formula, to find the midpoint and also to find the endpoint. And now a skill testing question using the endpoint formula. So using the endpoint formula, see how efficiently you can find the endpoint of my very long line segment. It's split into many parts, and all those coordinates are equidistant. If you tried it on your own, hopefully I paused enough so that you could pause the video and then do your solution, and now see if you agree with mine. So the way I would do this is say that the only thing I can do is to find this coordinate first. So I'm going to figure out what that is using the endpoint formula. I know that the midpoint is 11, 7. I know that my x value is negative 14. I have no clue what this x value is. And that the endpoint formula says I divide by 2. The same thing on the y side. So 6 plus y divided by 2. Once I come up with those values, I will have the endpoint. I'm going to use mental math this time. 2 times negative 11 is negative 22. Negative 14 plus x. Take the negative 14 across, becomes positive, and my solution is negative 8. Same thing on the y side. 2 times 7 is 14, equals 6 plus y. Mentally now, 14 minus 6 is 8, equals y. So the coordinate is negative 8, positive 8. Negative 8, positive 8. I'm now going to skip the next coordinate, so I'm going to use the original all the way to the left, the one I just found, skip one, and get to here. Because the coordinate I just found is now the midpoint between my two end blue stars. So now, staying with the color blue, I know that my midpoint is negative 8, positive 8. I know the x value I have is negative 14 again. I'm going to divide by 2. And the y value I have, one more time, is 6 plus y divided by 2. Mental math again, negative 16 equals negative 14 plus x. Take the 14 across, it becomes positive, so negative 2 equals x. On the y side, 2 times 8 is 16, equals 6 plus y. 16 minus 6 is 10, so my coordinate is negative 2, positive 10. And now to find the endpoint, I'm going to use the coordinate I found to begin with, the midpoint I just found, to find the endpoint I need. So I'll stay in red for this one. The midpoint is negative 2 and 10. The x value I know is negative 8. The y value I know is positive 8. I'm trying to find x, and I'm trying to find y. Mental math again, a little bit quicker. 2 times negative 2 is negative 4, equals negative 8 plus x. X in this case would equal positive 4, negative 4 plus 8. So I now know my x value. On the y side, 2 times 10 is 20, equals 8 plus y. 20 minus 8 is 12. And so the coordinate that I've asked you to find is 4, 12. A lot of times in math, we have a lot of steps to do to find the solution. And sometimes in math, there's an elegant or simple way or more direct way to get to where we want to go. So there's no need to find each and every coordinate in this case. You can be really efficient and do it in fewer steps. Diagonals of a parallelogram. This is more of a classic problem that you get to use these two formulas. So what we want to do at this point now is to verify the diagonals of a parallelogram with the following vertices bisect each other. Bisection means you're cutting it in two, and if you're cutting it in two, that would mean that the midpoints of both of those diagonals would have to be the same. So the way I would set this up is I would say that the midpoint of, I'll go alphabetical P and then R, is going to have to be the same as the midpoint, I'm using short form here, of Q and then S. I think I got my alphabet correct. So let's plug in our numbers now. So remember that the midpoint equals the addition of the x's divided by 2 and the addition of the y's divided by 2. That's the coordinate we're trying to find. So P and R would become -2 plus 4 all over 2 and 1 plus -1 all over 2. So that is 2 over 2 and 0 over 2, which is 1, 0. The midpoint QS becomes the two x's added together, divided by 2, and the two x's added together, divided by 2. This should look fairly familiar now. 2 over 2, 0 over 2 equals 1, 0. So we have now verified the diagonals of the parallelogram indeed to bisect each other. Thanks for listening.